In today's video, we're going to look at depreciation. Many items that we purchase depreciate or decrease in value over time due to usage. Some items can be depreciated by a set amount of the original price. The depreciation is determined by finding the percentage of the original amount, and this is known as the straight line method of depreciation. And we use this formula to calculate that, where S is the salvage value of the asset, VO or V0 is the initial value of the asset, D is the set depreciation amount per period, and N is the number of periods. Another method is the declining balance method of depreciation. In this method, the item's value depreciates by a set percentage of its current value. The value of the item never becomes zero. The depreciated value of the item after a set number of years is known as the salvage value, or S. I'm going to do an example now. So it says a small truck that was purchased for $45,000 depreciates at a rate of 25% per annum. By calculating the value at the end of each year using the declining balance method, find the salvage value of the truck after 4 years. And for this example, we're going to let S equal the salvage value. Now, to make our calculations a lot easier, instead of using the 25% per annum and then multiplying that by the 45% of the value, $45,000 of the value each year, and then subtracting it from that original value, we're going to make the calculations a little bit simpler. And what we're going to do instead is we're going to find the remainder of that 25%. So instead, we're going to find 75% of the value of each year. And that's because what we've done is we've subtracted 100 from 25, and that gives us our remaining value. So the salvage value at the end of each year will actually be 75% of its value at the end of the previous year. So after 1 year, what we're going to do is calculate S equals 75% of our original amount, which is $45,000. So what we will do is 75% times 45,000, which will give me $33,750. After 2 years, we are now going to calculate S equals 75% of not our original amount, because that's just going to give us the same answer, but of the value from the previous year. So $33,750. And that will calculate to $25,312.50. So after 2 years, the salvage value is $25,312.50. So now we're going to calculate after 3 years. So S equals 75% of our previous year's value, which is $25,312.50, which calculated will give me $18,984.38. And now lastly, 4 years, so after 4 years, because that's what the question asks, S equals 75% of the value from the previous year, which is $18,984.38, which will give me $14,238.29. So the salvage value of the truck after 4 years is $14,238.29. The declining balance method uses an application of the compound interest formula to determine the future value of an item. However, instead of the present value increasing by adding, the value is decreasing by subtracting, as you can see in the formula. In the formula, S is the salvage value of the asset after n periods, V0 is the initial value of the asset, and R is the depreciation rate per period, which is expressed as a decimal. Let's go through an example now. It says, using the declining balance method formula, calculate the salvage value after 8 years of a yacht purchased for $15,000 that depreciates by 10% per annum. The first thing we want to do is identify the different components of the declining balance method formula. So the first one is V0, which is actually 15,000. The next one is our rate, which is 10%, but we want it as a decimal, so we're going to divide that by 100, so that's 0.1. And lastly, N, which is our time period, and it's written in years, so it's just 8. So now what we're going to do is we're going to substitute that into our declining balance method, which is S equals V0, 1 minus R to the power of N. So V0 is 15,000, that's our initial amount. 1 minus our rate in decimal to the power of 8, because it's 8 years. So we calculate that, and that will give us $6,457.01. So the salvage value after 8 years for this particular yacht is $6,457. The salvage value of an asset can also be recorded graphically. So you may recall from our previous topic that graphs of assets that are appreciating by compound interest are exponential graphs. The graphs of depreciating assets are also exponential graphs, but the values are decreasing. So the graphs show a exponential decay instead of a growth. And you can see 2 examples below. Let's go through calculating one and actually graphing an example now. A car is purchased new for $40,000 and depreciates each year by 20%. Sketch a graph of the value of the car over the first 5 years and use the graph to determine the value of the car after 10 years. So what we need to be able to do is actually use the declining balance method formula to draw a graph and to use that graph to find out what our salvage value is after 10 years. So we're not going to use the formula to calculate that. Instead, we're going to use the graph. So the first thing we want to do is identify the different components for the declining balance method formula. The first one is VO, or V0, which is 40,000. Then we have our rate, which is 20%, but we want it as a decimal, so it's 0.2. And N is 5 years. However, what I want to be able to do is first draw a graph using those 5 years. So I want a set of values to give me some coordinates to be able to draw this graph. So N is actually going to equal 1, 2, 3, 4, and 5. And that's because what we're going to do is we're going to do 5 sets of calculations to get 5 sets of coordinates to be able to draw the graph. The first thing that I want to do is actually create a formula using the declining balance method formula that we can use to calculate all these values. So if you remember, our formula is S equals V0 1 minus R to the power of N. So let's substitute the values we do know right now. We know that S equals 40,000 and then 1 minus 0.2 to the power of N. Now, we can simplify this so that the rest of our calculations are a little bit more simple. So I can actually simplify this bracket here. So S equals 40,000, 0.8 to the power of N. So what we're going to actually do is use this to be able to calculate all our coordinates for the years of 1 to 5. So when N equals 1, S equals 40,000 bracket 0.8 to the power of 1. And all I've done is use this formula that we came up with here. And if I calculate that, it is 32,000. So my first set of coordinates is 1 and 32,000. So after 2 years, S equals 40,000, 0.8 to the power of 2. And that gives me 25,600. So here is my second set of coordinates. After 3 years, S equals 40,000, 0.8 to the power of 3, which gives me 20,480. So third set of coordinates. After 4 years, S equals 40,000, 0.8 to the power of 4, and that gives me 16,384. And lastly, when N equals 5, S equals 40,000, 0.8 to the power of 5, and that gives me 13,107.20 cents. So as you can see, I now have a set of coordinates that I can graph, and I'll be graphing a exponential graph. So using these coordinates, I will draw a set of axes with age on the horizontal axes, and value on the vertical axes. I'm then going to plot the points and join the points with a smooth curve. And that's what I've done here. So as you can see now, this is as accurate as I can get it. And it's asked me to estimate the value of the car after 10 years from the graph. So you need to make sure that you're able to see the value 10. Now here is my 10, so after 10 years. And if I go up this value here and across, it is actually approximately $4,000. So I can approximate from the graph that the value of the car after 10 years is $4,000. If I had to actually calculate it using the declining balance method formula, accurately, it will tell me that after 10 years, the car's value is $4,294. So in terms of accuracy, the graph is quite close. So it's always good, as always, to use our formulas, substitute in 10 for years, and find out what that actual value is to see how accurate your graph is.